All right, so about 10 seconds left until day 3. I decided to wake up early for this one and do it live. Let's see if this is a mistake or not. It's about 6 a.m. here right now, so let's see. Wow, it comes online. Beautiful. Boom. Let's see, day 3, rucksack reorganization. One elf has done the job of loading all of the rucksacks. I don't know what that is, with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. Each rucksack has 2 large compartments. Okay, all items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Okay. They also made a list of all of the items currently in each rucksack, your puzzle input. But they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and A refer to different types of items. Okay, so, we can check that later. The list of items for each rucksack is given as characters, all on a single line. The list of items for each rucksack, is given as a list of characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent the items in the second compartment. Okay, so each line is a rucksack. First half is first compartment, and then second half is the second compartment. Okay. Well, the second half, for example, suppose you have the following list of content from 6 rucksacks, right? 6 lines, 6 sacks. The first rucksack contains the items, all of these. Its first compartment contains boom, while the second compartment contains the items boom. The only item type that appears in both compartments is lowercase p. Okay. The second rucksack's compartments contain boom and boom, and the only item that appear in both compartments are uppercase L. Okay. And then third, only common item is P, only shared, only shared. Okay, so all of them here in the examples at least have one shared item between the first and second compartment. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase item types A through C have priorities 1 through 26. Okay. Uppercase item types A through C have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16, lowercase p. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Okay, so let's see. We're going to generate day 3. Folder already exists. Okay, because I tried to do this before it was open and that didn't work. So let's do this, generated folder. Day 3, we're going to work in this file and let's look at the input. Okay, so here is our input. Okay, very nice, very nice. So we're gonna have to, each line is a sack. First half versus second half. Find the common character. Sum the scores. Okay, so the first and second, first we're going to split the line, right? And I guess it would be something like this, but no. Maybe we need to do this because line has length, right? So we could do maybe not split then, but like slice. Start and end. I mean, if we start at 0 and then we go to line length divided by 2. So that's the first one, right? Comes first. Second will then be, let's see if this is actually giving us the right answer. First, second, and we need the input data, and we are gonna do just the first line. And actually, I had a nodemon yesterday, so let's try and use that. So npx nodemon 1.ts. Okay, so v to g. And then b to f, right? Yeah, so that seems to be correct. Good. So then let's keep that. So those are the first, that's the split. We're gonna need some kind of map. And what do we do here? Like, how do we find the common character? I guess we can just walk through one of them and see if that character is in the other one until we find it. Because I'm assuming, I mean, there's going to be one common one. So, okay, so maybe we... do we need them to be, do we want them to be arrays? I guess if we just split them, I guess this will split them on characters. So let's then do first for each and C for character. We can do that. And then if second includes C, then what? Then we've found the character. Okay, so maybe const chars equals an array. Then chars push C. So I think here at the end, we are gonna have a bunch of okay, so this is my TypeScript thing bugging, but this is just going to be an array of strings. Easy. Okay, so we have a bunch of characters, the common ones between them. Now we need that kind of, we need the map. Because I think we can just do scores or like priorities. And that's the alphabet. So I guess first we do this, and then we're gonna do chars for each. We can call this C again, that's fine. And then I guess we need to find the position. Can we do this with a string? I mean, I assume we can. Index of C. So then let's score equals 0 and score plus equals weight. So position, and that's going to be, we need to plus 1 here as well because the index are at 0. So this, I think, could actually be enough for the first part, right? So we're getting a score here. Let's see if this is correct. That's not the right answer. That is not the right answer. Okay, so let's try with like 3 of them. Just to check here. There's 4 of them. There's not supposed to be 4 of them. There's supposed to be 3 of them. Then we're not, maybe we don't do 4 each. Can we break in a 4 of? Maybe we can do this. Or, I mean, okay, QPN. So if we do 4 of instead, and in this case we can break, so I think that's good. Now let's check our score. It's 97. And hopefully this is the right answer. All right. Of course it's not 97. Instead, it might be this boy. Now I have to wait a minute. So let's try again. God damn it. Okay, why not though? Why not though? I've missed something. I've missed something. One of these letters. So W. I missed W. I think a minute has passed already, so let's check. We get a new number. And let's try this one. That's the right answer. Okay. Okay. First gold star. Feels good. That was a little bit silly. Let's check it out. Part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3, they're divided into 3 groups. And for efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group. But each group can have a different badge item type. So in the above example, the first group's rucksack are the first 3 lines. Okay, so they're grouped by lines of 3. And the second group's rucksacks are the next 3 lines. Okay. So I'm guessing then that the input is divisible by 3. It is. We have 300 items. It's going to be 100 groups. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. Okay, so we don't care about compartments anymore. We just care about the whole rucksack. This must be their badges. In the second group, their badge item type must be Z, uppercase Z, because it's in all 3. Priorities for these item types. Priorities for these items must still be found to organize the sticker attachment efforts. Here, there are 18. Okay, so the points still apply. There are 18 for R for the first group and 52 for Z for the second group. The sum of these is 70. Find the item type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of those item types? Okay, so in here, and we're not going to run number 2, we're going to run number 2 instead. Very nice. And in here, we're just going to need the line, right? We are going to need the line. And do we have an index here? We do. So maybe we can do some thinking of grouping them, right? So I guess we can just have an array of arrays, like groups. It's going to be an array of strings, maybe. And then the index here, let's see, and then let current group equals an array. This is going to be an array of strings. And I think here line array equals line split. Actually, let's get this up again and let's do 1, 2, 3, 1, 2, 3. So let's just work with these first. So we have a line array and then like current group, and we will push that into the current group. So line array, current group push, and then if I modulus 3, then we can push the current group into groups and set current group to an empty array. I do think that's fine, right? Me having fun with TypeScript configuration is just going to bother us right now. So that's the linting, I think. TypeScript might be a mistake, right? Right, we don't have any score. So then what do we get for groups here? What do we get for groups here? We get an array and then maybe splitting them is just overkill, right? Like, why do we even need to do that? Yeah, so if index is over 1, or it's not the first index, right? And yeah, we have to do the index plus 1 modulus 3 if it's not that, or if it's the last item, then do the grouping. So I think here we're on the last item, we're doing the last grouping, and I think we have all of the groups. Jesus. Okay. Okay, so let's move on from here. We do have all of the groups. What was the next thing we need to do? Now we need to figure out, we need to find the letter. So we're gonna do groups for each group. And then, so in this case, a group is now an array of 3 strings. Line 1, line 2, line 3 equal group. And then maybe we can do line 1 or const L of in line 1 if L line 2 includes L and line 3 includes L, then const items, this is going to be an array of strings. And then if this is the case, items push L, items push priorities, index of L. All right, so now this is going to be an array of numbers pushing the index of each number. Do we have a don't, or maybe why do we push them? Why don't we just use score and say score plus equals this guy, and then log score here at the end? Could this be the right answer? It's not the right answer. Okay. Oh, wait. Double check. No, we are with the full input data. Right. We need to break, right? 60 now. Okay. 60 now. That's better. We forgot to break. So now the new score is 2,603. So let's try that one. It's not the right answer either. Plus one. Plus 1, 62. Yeah. So I think this one we need to try. So we can't do the index. We need to do index plus 1. Okay, 13 seconds left. We have this copied right. Let's try this. That is the right answer. Okay, beautiful. So we made it to day 3. Very nice. All right, I'm gonna wrap this up. This was interesting. It was actually fun doing it early in the morning. It's now 7 a.m. So this took me about an hour. I'm tired in the morning, but I think I'm gonna try and do this, if not immediately, 6 a.m. in the morning, at least early in the morning. So thanks a lot for watching. This was day 3. We got 2 stars today again in about an hour. Let's see what happens tomorrow at day 4. If you enjoy this, please like the video, maybe subscribe to the channel. I'll be creating more web dev related content moving forward. Okay, have a great day. Ciao.